solving systems of linear equations with 0, 1, or infinitely many solutions. So our instructions here say we have two systems of equations given below. For each system, choose the best description of its solution. If applicable, give the solution. So we know we have three different types of systems when it comes to linear systems of equations. Either the system has no solution, the system has a solution, or it's a one-solution system, or the system has infinitely many solutions. So I'm going to work these problems separately. So we'll start with number 1 here. And I have two equations in y equals form. So this top equation is telling me wherever I have a y, I can replace it or substitute 3x plus 9. So I'm going to substitute the 3x plus 9 for the y in my bottom equation. When I rewrite that down here, it's going to be 3x plus 9 equals, because I put the 3x plus 9 in for y, equals 3x plus 4 on the other side. And then I'm just going to solve this equation, or proceed to solve this equation. So since I have variable terms on both sides of my equals, I need to zero one of them out. So I'm going to subtract 3x to zero out the x term on the right side of the equation. But to balance my equation, or keep it balanced, I also have to subtract 3x on the left side. And when I simplify, all of my x's are going to drop out, or zero out. I have no x terms left. But I am left with a 9 on the left and a 4 on the right. Now if I look at what I'm left with, 9 equals 4 is a false statement. That's not true. 9 doesn't equal 4. So since all my variables dropped out and I'm left with a false statement, I'm going to mark the system has no solution here. Now, if this would have happened and all my variables would have dropped out and I would have been left with a true statement, such as 9 equals 9, let's say, just for instance, if I had been left with a true statement, then I would have marked the system has infinitely many solutions. Now, let's go on to example 2. So here I have two equations in standard form. I need one of them in either x equals or y equals form. So I look at both equations and just decide which one would be simplest to rearrange. Since this one has an x term that's just an x by itself as the term, I'm going to put this one in x equals form. Because the only thing I need to do is get rid of this plus 3y. So you're going to subtract 3y from each side. Or as a little mental shortcut, you can imagining that 3y just jumping over the equals to the right side. When it jumps over the equals, it goes from being positive 3y on the left to being negative 3y on the right. And then I also have this negative 1 on the right. So now, instead of x, I can replace x with the expression negative 3y minus 1. So up here, in my top equation, I'm going to replace that x with the expression negative 3y minus 1. So let's go ahead and rewrite this. I have negative x, so negative, and then I'm going to put parentheses in place of the x because I need to substitute in this expression right here. Negative 3y minus 1. Then I have minus 3y equals 1. So now that I've rewritten the equation, I'm going to go ahead and just solve it. The first thing I need to do is distribute this negative, because really you can imagine this is negative 1. There's kind of a hidden 1 right there with that negative. Negative 1 times both of these terms. So negative 1 times negative 3y will be positive 3y, and negative 1 times negative 1 is positive 1. Then I also have this negative 3y equals 1. Now if I go ahead and combine like terms, 3y minus 3y, if I combine those together, it equals 0, or they just zero out, and I'm left with 1 on the left equals 1 on the right. Now, as I was saying earlier with this example, if all your variables drop out and you're left with a true statement, then the answer is the system has infinitely many solutions. Now, if I would have solved either of these two problems and my variables didn't all zero out, and I could actually solve through and end up with x equals a value or y equals a value, then I would have chosen the second option, the system has a unique solution, and I would have listed the values, the x and the y values from my solution.